One of the best ways to prepare for mathematical conversations with our students is by anticipating students' thinking. When we try to imagine what our students might say, we prime ourselves to better hear, understand, and respond to their ideas. Let's look at this image of dice, where we ask, which is more, and anticipate some of the many ways students might think about and answer that question. First, it's important to note that some students might view these simply as objects and interpret the question as which side has more dice, and then they might count them individually. Students who interpret it this way might count them individually, 1, 2, 3, 4, 5, 6, and then count on the other side similarly, 1, 2, 3, 4, 5, 6, and arrive at the answer that 6 is equal to 6. They are the same. But we all know that there are other ways of interpreting this question, to be thinking about not the dice, but the dots on the dice. And one answer to this question could simply be that students think that the blue side has more dots because it looks like more dots. This kind of gut level visual estimate is actually quite appropriate and shouldn't be dismissed as lacking mathematical reasoning. Instead, we should ask, what did you see that made you feel that way? Students might notice that over here, there are 2 6s, a 5, and a 4. These are the large numbers on a dice, while on the other side, there's only 1 6 and no 4s or 5s. This is pretty good reasoning that you can assess visually by just asking, which do we think is more? But what I would ask next in a classroom is, what other evidence can we gather to prove that the blue has more dots? Some students might do a variety of things in order to count. They might, for instance, begin to group the dots. They might see that there are 10 here and 10 here and 6 remaining for a total of 26 on this side. They might then ask themselves, how could I make 10 on the other side? And see that 6 doesn't have a 4 partner, but it does have a 3 and a 1, a 10. And what remains is 2, 2, and 3 for a total of 7, making 17 on this side and 26 on this side. They're not even close. That visual estimate was quite good. Students might make other kinds of groups in order to count rather than counting individually, although some students might simply start joining and notice, say, 12 here and 4 more makes 16 and 3 more makes 19 and proceed from there to add end after add end to again arrive at 26 and 17. But there's an even more sophisticated way that students might compare, because in the end, we don't actually care how many dots are on each side to answer the question, which is more. We just want to know which has more. And one way that relies on relational reasoning that students might use is to decide which dice they even need to pay attention to. They might notice that there are some dice in common on both sides, and if they're in common, they're equal, and therefore they don't change the relationship between the two sides. For instance, there's a 6 here, a 6 here, a 2 and a 2, a 3 and a 3, and that makes them all equal. What remains on both sides are these dice. On this side, what remains is 6. On this side, what remains is 15. 15 is far larger than 6, and so yet again, the blue side has more dots. There are a variety of ways that students might think about the question, which is more, and go about answering that question and providing evidence. And you can imagine that in a classroom full of students, you could have a very rich conversation about how to answer this question and to coordinate different forms of evidence. We encourage you to give this a try with your students today.